All right, we're going to take a look at one last method for quantitative variables called analysis of variance. We've looked at tests for one population mean, and we've looked at ones for two population means, both the matched pairs and the two independent samples. Analysis of variance, which is commonly called ANOVA, will allow us to compare the mean of a single variable for several populations. In order to do that, we're going to need to use the F distribution. So let's go take a look at that. Okay, so our F distribution has the same property that all distributions in statistics have, which is that the total area under the curve is always equal to 1. Okay, now some of these other properties are going to vary depending on the distribution you look at. So let's take a look at these ones that really distinguish the F distribution from the other ones. So this one is going to start at 0 on the horizontal axis, and it extends indefinitely to the right, so towards positive infinity. It is right skewed, meaning that tail is on the right-hand side. And it actually has two numbers for its degrees of freedom. So the first one is we commonly call the degrees of freedom for the numerator, while the second one is the degrees of freedom for the denominator. And if that's making you think of a fraction, that's actually where we're going with this. So the F test statistic is based on a fraction, and those degrees of freedom are related to that. And we'll take a look at that in just a little bit. Right, so the test we're going to look at is the simplest one. It's called a one-way ANOVA. Okay, and it's going to compare the means of several populations for one specific variable called our factor. Okay. And there are a couple of assumptions that we need to check in order to be able to use this process. So the first is that we have a simple random sample, which has kind of been our bread and butter this whole way through. The next thing is that you have independent samples. So the samples you're pulling from each population are independent. You want to check that each of those samples is normal. So that can get a little bit time consuming because you are comparing multiple means there. And typically what we're looking for, these sample sizes aren't always very large. So we're just looking to make sure that there isn't something that's super out of the ordinary in terms of looking for that normal distribution. And then the last assumption or condition is that we have equal standard deviations, which probably on the surface sounds like that's not very likely. But in fact, it isn't. But that's not a super strict requirement. So the normal one isn't super strict, and this equal standard deviations also is not very strict. Okay, and one of the things that we look at for that last one there is something called the rule of 2. So what you want to do is find the standard deviation for each sample that you have. And then you're going to take the largest standard deviation from your samples, and you're going to divide it by the smallest standard deviation. And you want this to be less than 2. If it's less than 2, then we call it good enough on the equal standard deviations, and we just keep trucking along with what we're doing. Analysis of variance compares the variation due to specific sources with the variation among individuals who should be similar. So specifically, ANOVA tests whether several populations have the same mean by comparing how far apart the sample means are with how much variation there is within the sample. So if the variation among the sample means is large relative to the variation within the samples, we can conclude that the means of the populations are not all equal. All right, so that's a lot of words to get around to working on this concept. So let's look at how we actually calculate that test statistic in the next video.